Good afternoon, ladies and gentlemen. This is probably the biggest audience I've ever seen on the stage. Cool.
Same with me. My name is Jörg Dürre, and this is...
Yeah, my name is Gunnar Töhle. We'll show you how to power stuff without paying Vattenfall, E.ON, the national grid, whatever, where are you from? And without paying anything at all, basically. There's a small piece of equipment that you need. Cool. First things first, where's this? That's not the moon. That's not Mars, that's Iceland. You might have heard of Iceland, it's a country full of ice, and there's no sun in winter, but still they power their gadgets, like this one, with photovoltaic power. Seems to work. So why not make it work for you? It's
It's a bad quality of that photo anyway.
Yeah,
So.
the photograph isn't too good. I'm sorry for that. Let's see if this thing works. Yeah, wonderful. Who came by train or by car? Show of hands, please. Oh, wow. That's a lot. You might have seen loads and loads of square kilometers of solar panels in Brandenburg around Berlin. You might have seen loads of windmills. You can have them too. One of those costs at least 1 million euros, if not more, and generates enough electricity for a village. So you don't need a big one. Komm mal hier rüber. Well, we'll show you a small, very short introduction into physics. We'll keep it short. And what's more important, we'll show you how much power you can actually get from the sun or from wind or whatever. And then we'll make you calculate how much power you need. Who of you got laptop with you? Oh, that's quite a lot. Wonderful. It's the Chaos Computer Club. And did you bring your power brick? Your Netzteil in German? Oh, cool. We can do it. And then we'll show you what you need. Then we'll tell you to Google for the schematics. And what's much more fun, how to put power into the electricity grid. And because Jörg brought the sun, show the sun. And
It's a very little
this
sun.
is our sun.
It's a 500-watt Baumarkt sun.
Yeah. And we intend to actually put electricity into the Berlin grid right on stage. Let's see if this will work.
Yeah. Nobody please tell anybody because it's not really correct, but we tell you later.
I don't know if it's actually illegal. Is it?
Later.
You've heard of renewable energy before, I suppose? Do you read newspapers? Yes, you do. And there's a lot of sources. You've heard of photovoltaics, it's what you can see here. You've heard of wind power, and then there's a lot of strange other stuff. There's, in France, there's a place which makes power from the tides. Or you could actually drill down into the ground and get electricity from that. There's loads and loads of opportunities. The most important one is the sun. And if you think about it, most of the other stuff you can use, that's the sun. Water flowing down rivers can be turned into electricity, easy. That's solar energy. Can you tell me how? Well, I'll tell you. It's because the sun evaporates water from the sea and gets transported to the mountains, rains down. You've all seen that in elementary school. And flowing water gets electricity. You could actually use the kinetic energy of moving planets. Sounds weird, but that's what this place in France does. It makes electricity from the movement of the moon around the Earth. Yes, are there physicists here? I know at least one. And you will notice that generating electricity from the movement of planets should slow down the movement of planets. Yes, it does. But, well, so what? And what's really quite funny is you can even use atomic power, and it's called renewable energy. It's when you drill down into the ground 3 or 4 kilometers deep, you get 100 or 120 degrees hot water, can be turned into electricity. That's actually made from radioactive decay of metals in the Earth's core and from residual heat from the Big Bang.
So it's 50-50. I would love to do that privately, but we have to invent a real cheap drilling machine then. So if anybody feels motivated, go ahead, please. Then we make it green.
This slide will show you in clear and easy to remember colors, green and red, what's good for you at home and what's not good for you, because it's too expensive, too difficult, too big. Our recommendation is use the sun, easy, cheap, doesn't make any noise, no dirt, wonderful. You can use wind at home. Do you have a garden or a balcony? Yeah, so you can use wind power. And in theory, if you're living near a stream, you can actually use flowing water. It's a rare occurrence, but some do. Enough? Next slide. Engineers are creative. This is one wonderful power plant here. It actually runs on the difference of salt concentration in water. Do you know a place where water with different salt concentrations meet? It's where a river flows into the sea. And it can be done through a process called osmosis. And it has been done once. If you know how to make a good osmosis membrane, please come forward and have a talk here next year so we can turn all our river mouths into electricity generating machines.
Then a strange idea of Gunnar again, just build a very small dam here and then the water evaporates here in the Mediterranean and then we have a good power plant here. But maybe later.
Well, it's not actually my plan, but it could be done because the Mediterranean, it loses more water than its rivers put in. If you dam it here, the Mediterranean Sea will evaporate. You'll get huge, amazing beaches. You will get, well, you might probably get earthquakes due to the missing rate of water, and you will get a really, really high difference of water levels at this point. It can be turned into electricity, but we shouldn't do that. Question?
200 meters for some 10,000 additional square kilometers of pressure.
Yeah, sounds good, doesn't it?
You should repeat the question.
I should repeat the question, and it wasn't really a question, but it was 200 meters for some 10,000 square miles of desert. Sounds good. So let's do it tomorrow. Well, there's some more physics left. What's energy? Energy is the ability to do work. That's all. Do you like Club Mate? You probably do. That's a form of stored energy. Why? Because if you drink it, you can do work. Question for the audience? Please calculate the energy content of Club Mate in kilowatt hours. It can be measured like all physical variables. And, well, in kilowatt hours. That's what your electricity company bills you, kilowatt hours. Go look it up. It has to be, there's a difference between kilowatt hours and watt. What? Watt isn't energy, it's power. The more power you need, the more energy per time you need.
The last line is from Gunnar. For the technical IT audience, that kilo actually means 1,000, not 1,024.
So you're all set, aren't you? Next slide. Off you go. Well, that's enough physics for now. About the sun. The sun is shining all day, all night. Not always in Berlin, but so what? And it's shining at a very constant rate of 1.361 kilowatt per square meter. That sounds like quite a lot. We'll compare that to your laptop's power requirements later. And there are quite a few problems. There are clouds. And there's the problem with the nearer you get to the poles, the less sun you get in winter. Well, there's winter. And then there's the thing about efficiency. Those photovoltaic panels over here, they only convert about 10 to 15% of the sun into electricity.
That's old stuff. And about the longitude and the solar constant, basically wherever you go, you can just move the solar panel according to the sun to get the maximum input then.
Well, as we are now based in Berlin, you can calculate how much sun you get in a year. And what's a quite realistic number is 100 kilowatt hours per square meter in year in Berlin. Most of that is in summer, and only a few kilowatt hours are in winter. We'll talk about storage later. But we won't tell you too much about how to calculate how much sun you get, because there's the internet. Have you heard of the internet? Yes. In Germany, follow this link. Choose the place you are living at, and you can even enter the form of your roof on your house, and it will calculate how much power you get. Easy. Don't need to do it yourself. And some cities have something called a Solarkataster. Is there anyone here who doesn't speak German? Yeah, that's not too much. You're left out now, sorry. And but we've got imagery so you can understand what it is. A Solarkataster is a pretty fancy measurement technique. What you do is you fly over a city, you measure the roofs, and you make a map of which roof in your city is good to get solar power from. Let's see for Berlin. Where are we? Well, you don't have laser pointers. We're here. In this aerial photograph of Berlin, area around Alexanderplatz, red is, it's very good for solar power. Yellow means it's not so good. And well, I would have picked green. But that's Berlin for you. Go look that up. If your city has one and your roof is perfectly suited to solar energy usage, do it. If there is no Solarkataster for your place, please go upstairs. Find those people with those small drone-like helicopters with those 4 rotors. I don't know how they are called. And just ask them. So could be possible.
We learned something else today. Maybe social hacking could also work. Just ask your local politician and demand something like that.
Maybe they'll get it. Who knows? Yeah, then there's wind. If the sun isn't shining at your place, who knows? The wind might be blowing. How do you find out how much wind there is at your place? You could go out and stick your finger into the air. That's not very scientific, and it doesn't actually get you any numbers.
Okay, now you get your gadget.
We'll try this now. How much wind is this? Not too much, sorry. And can you fix it here? Wouldn't this be? Oh, sorry. Doesn't work. There's a problem with wind. It's different at every place. You can't calculate it. You have to actually measure or at least forecast wind speeds. As you know from traveling to Berlin, wind is now a commercially interesting resource. This poses problems for us. Is any one of you rich? No. So we have to get to wind data for free. There's one source in the internet right here. What it gets you is wind maps like this. The resolution isn't too good. If you are a researcher or if you are employed at a university, go and try the British Atmospheric Data Center. They are really good. They have wind data from all over the world, but they'll only give it to you if you research with wind data. Who of you can do this? Nobody, too bad. Oh, I forgot to talk about fluctuations, sorry. You might have noticed that the sun isn't shining all day at a constant rate. Let's go back. And if a cloud is passing, you don't want your laptop to turn off, do you? You have to deal with fluctuations. For photovoltaics, fluctuations happen on an order of 1 minute, maybe. You all have witnessed clouds passing over your place. They go by in 1 minute. Deal with it. For wind, it's easier. Wind is a bit more constant. You have fluctuations on the order of about 15 minutes, more or less. You have to deal with that too, but it's less difficult. We'll talk about energy storage later. How do you actually get electricity from wind? Well, use one of those, if you've got money. Those are horribly expensive. This thing produces about 50 watts. You all know what watts is now? And it costs more than 800 euros or 1,200 US dollars. That's too expensive, sorry. So build it yourself. It can be done from car alternators. Google for it.
Actually, that would be interesting. Somebody has to do it because those small wind machines are extraordinarily expensive. Even though if you ask in China, the small wind machines, you can't pay. So if anybody feels like it, please go for it.
Really, there is a market niche here. Do it, please. Well, now you know how much energy you can get, or at least you can look it up. How much energy do you need to power your stuff? That's a question.
Now, if you're interested in wind energy, there's actually a small book in German.
Microphone.
We've
got a microphone, but it doesn't work.
If you're interested in wind energy, there's actually a small book, I think, or maybe two now, by a guy who's actually called Hacker in German, and they are very good background material. And he also has some nice statements about the quality of these wind machines that you can buy from China. And then you'll probably wait a little bit more before you get one yourself.
That was our conclusion, so we left out wind for the rest of the speech.
If I may add, there's a series of books. It's called Einfälle statt Abfälle, Inventions instead of Waste. And he describes windmills up to, I think, 700 watts or so, and he builds them from waste. All you need is an old car and some more stuff.
You can actually visit that guy. He lives in Kiel. That's about 400 kilometers from here. They are great and very cheap. Well, now you've got your power. What can you do with it? Remember those calculators from school? They don't really need any power. This is indeed a solar panel. You can power them with, well, a match maybe. There's quite a few numbers on this slide. You can read them yourself. If you want to power an Arduino, did I pronounce it correctly? Oh, cool. Well, I think you already know how much power it needs. It's not much. We found out how much power a Kindle needs. It only needs power when turning pages, and it's a pretty small amount. You can read lots of e-books with solar power. It's not true? Is this a Kindle with...
It will be empty in 3 weeks if you don't even use it.
Oh, you've got better numbers than us. Wonderful. I will repeat that for the stream listeners. We've got an expert here who is much more knowledgeable than us, which is good. And Kindle will lose all its power in 3 weeks. Can you calculate how much that is? Could you calculate how much watt hours that is? Let's meet afterwards. The iPad seems to use about half a watt, more or less, depends on what you do with it. And let's go to the much more interesting stuff, like you.
This number is also questionable.
Yes, definitely.
It's true if you almost do nothing with it, but it's definitely not true if you do something with it.
Yeah, wonderful. Questions. Our numbers are questionable, yes, definitely. Well, some more interesting numbers. They are as questionable as the others, but at least the range should be all right. Human beings, like you, sitting here, each one of you is about 80 watts of heat, not electricity, of course. And have you been on those? They use about 16 million watts when accelerating at full speed. Compare that to the iPad. 16 million iPads. And a pretty impressive number is the energy consumption of Germany, down here.
That's
Okay.
only electricity, not the energy.
Very good. Can you actually pronounce that number? And the energy consumption of Google, 260 million watts, not too bad. Your homework now is try to power Google from your town. How many square miles do you need? It should be quite a lot. Well, now build it yourself. You need parts lists, you need schematics and instructions, but you're smart enough, so we left it out. Is it all right? No, it seems to be all right. And well, what you need is some sort of electricity generator, solar panels, wind, whatever. You need a charge controller. You probably don't. You need at least a diode. Why do you need it? Solar panels will discharge your battery at night if you don't put a charge controller or at least a diode into the circuit. Don't do that. You need a battery. Our recommendation currently is lead-acid batteries. They are cheap, they are very heavy, but they work. You probably need some kind of voltage converter. There will be another exercise in this lecture now. Turn on your laptops and see if you can spot the requirement voltage your laptop needs. It's probably not 12 volts. So you need a converter. And you need some cables, of course. When shopping at an expensive place, the Germans know Konrad, don't they? You can get by with about 100 euros and shopping at a cheaper place like eBay or the scrapyard or wherever it's cheaper. It's the easy way. Wow. And you could actually go large scale, buy a few square meters of photovoltaics, and it adds up to this. Do you care to explain this?
It's a bad slide, but we just put it in half an hour ago because we wanted to have a money calculation in there. We looked up what Vattenfall charges at the moment for electricity, and that is 22.56 cents per kilowatt hour as of today for really bad energy from
coal and lignite, and well, it's brown and it stinks.
And then we took the lead-acid batteries and looked how much that would cost if we want to store. And we came up with 20 cents per kilowatt hours. So that would add up for any stored kilowatt hour.
There are quite a few assumptions in here. What did you see? Okay. There's a question.
Is there
Microphone, please.
Is there a difference between a car battery and solar battery?
There are technical differences, but for the easy assumptions, we just took car batteries. Car batteries are optimized for some other usage because they have to stand the cold and have to have the big currents to start the car, which you would not need for solar batteries, but they're priced too high. So we took the very cheap approach. So there would be better batteries for that purpose.
Yeah. Car batteries will break earlier, but they are dirt cheap. So use them. There's another question, isn't there?
So in the numbers that you've got here, I mean, my euros to US dollars is slightly, isn't the best that it could be, but when I'm looking at this, I mean, so this is kind of like the cheapest that you were able to get it? Because I mean,
Sure.
I'm not familiar with European power grid, and in the U.S., yes, we're wasteful, and we do all kinds of stuff. But I mean, our cost for power, like just all in, all the taxes, everything comes out to normally 11 to 12 U.S. cents.
We know. But
So,
we are
we know.
being tricked by the electricity companies, and that's why we're here, to tell you that's not necessary.
Okay.
Yeah.
Perfect. Awesome.
I'm very sorry, but this talk will probably not be too interesting for you. Bad luck.
It's just based on really strange, you have to put market in, what's it called in English?
Well, it's not really a free market. It's kind of state-run. Republicans would say communism or something. And that's what we get here in Europe.
I calculated for myself the percentage of net costs that I pay is 45% of total cost. So we have to do it on our own, and then we force the big companies to come down with the prices, and then we proceed on how close we are to this.
Well, let's go to our assumptions. Our assumption was, for this calculation, you could actually disconnect your home from the electricity grid. It's possible. It's not too expensive. What you need is batteries. We chose car batteries. How many you need? Well, depends on what you need. And we've got the assumption that you use most of your power at breakfast and in the evening, because as a fellow hacker, you go to work. So you don't need electricity during the daytime. This assumption comes through in that we need to store 70% of our electricity in batteries and can use 30% of the electricity we make from our roof directly. It's just an assumption. It's as questionable as all our numbers are. And
with some technical optimization, you can, of course, change it, but that's later.
And there's another assumption which we just kind of picked from Wikipedia, which is a wonderful source, as you all know. That's if you buy solar panels, you get a loan from your bank for 25 years. You can actually produce electricity from your own roof for 13.8 euro cents per kilowatt hour. See for yourself, or edit it in Flamers afterwards.
So we have to say a few words more. In Germany, if you use the Renewable Energies Law, the Erneuerbare Energiengesetz, then you would get a fixed compensation for 20 years. But after 20 years, the photovoltaic system is not broke. You see your scientific calculator, the solar panel will stay on forever. So after 20 years, you still have 80% power left. So what we did is calculate with 25 years and not with the 20 years that are always in the papers. So next time you read something about the cost of photovoltaics, they always calculate with 20 years, not a year more, because in the 21st year, the cost of photovoltaics would be almost nothing.
Yeah, you already paid back your loan. You get free electricity. Great. Well, what we came up with is electricity from your own roof costs 27.8 euro cents per kilowatt hour. It's more expensive than now, but the German Energy Agency just said electricity prices will rise 20% next year. We are moving closer.
Years.
And if you want to be on a cheapskate, deduct €5.90 fixed fee per month, and it pays you nearly, well, no, not nearly, your investment costs. Did you all understand that? Let's sum it up. It's not expensive anymore. Compare that. 27 cents, 22 cents, not too bad. Well, where to buy? You get PV cells everywhere, even at Conrad. That's kind of the most expensive place you could buy them. The cheapest place seems to be China. If you don't want to go to China, go to eBay. You just, which is China basically, yes, but actually it gets delivered to your doorstep. That's cool. And it seems like currently prices are at €1.20 per watt. You measure photovoltaic cells not in square meters but in watt, because that's what's actually interesting. Go buy your lead batteries from a cheap car shop. You all have one next door. And, well, we've talked about wind generators. Build your own. Or if you are rich, you can buy one of those ready-made things. The company I named here, that's not our company, and they don't pay us. And you need your charge controller, or at least a diode, which you get from your local Radio Shack or whatever, for next to no money. Take care with those batteries. They contain sulfuric acid. Please don't pour it over your hands or other body parts. So it doesn't look nice and it doesn't feel very good. Please don't. And definitely take care if you are experimenting with lithium batteries. They don't contain sulfuric acid, but if you charge them incorrectly, they might ignite, burn, melt your house down. Don't do that, please. Now we've said that, let's put power into the grid.
Okay, I'll entertain you in between, and he will do the real thing.
Okay, if you insist. Mr. Cameraman, how far can you come to the stage? How near can you come to the stage? Sorry for my English.
Actually, about the lithium batteries, it's not all that dangerous. It's not ready for home use yet, but I have talked to some German companies that are ready with lithium ferrum phosphate batteries with titanium anodes, and they will have cycles far better than actual batteries now, so that we come down
They will last forever, basically.
Basically, buy one, use it for the rest of your life. And once we are there and we have the photovoltaic system, we have an amazing future.
I'm sorry.
So, putting your own power into the public grid, usually at home it can't be done. We show you how it can be done. In Germany, we have the Erneuerbare Energiengesetz, Renewable Energies Law. Anything about 1 kilowatt, 1,000 watts. Gunnar, how much is this, what you have there? 50 watts?
Those are 30 watts each.
30 watts each.
Far too tiny for Erneuerbare Energiengesetz.
So you need a few of those, or a little more better ones, like 5 of the big panels. Then you can use the Renewable Energies Law, but you have to fill out lots of papers. Once we put this on the grid, theoretically, then the meter would go backwards, so we don't tell anybody. And once the grid company recognizes what we do, then most likely you will have a digital meter and not a Ferraris counter, as it is in the most households at the moment.
This is a magic box.
The grid tie inverter. When we really do a bigger installation at home, then we have to take care that the local electrician does not get electrocuted. So there have to be some rules to be followed. It's a German VDE rule 0126 that defines what this little box has to do, that actually on the power plug. Where's the power plug?
The power plug?
Anything.
Right here?
Like here, it's absolutely not allowed that electricity comes out here, but with such a box, it does. So,
Yeah. Yeah. Make very sure you include this in your own circuits. There's a good reason for that. If your power grid at your place goes down, which happens, and the sun is shining, you, with your own power parts, are delivering electricity into a grid that your local technician is trying to repair. Don't try him. Really don't. He'll die.
so what you really do is just fix it to the grid with an approved electrician, because you're required to, by law, to use one. So once it's attached to the grid, then there's no danger anymore. If you do that in Germany, or if you buy electricity in Germany, usually you have your local supplier, the grid supplier. In this case, we took the example of Vattenfall. In German, it says you have to take care, sicherstellen, dass von seiner Eigenanlage keine schädlichen Rückwirkungen an das Elektrizitätsversorgungsnetz möglich sind. Und der Anschluss von Eigenanlagen ist mit dem Netzbetreiber abzustimmen. So we have to take every measure that there's no danger, and we have to talk to the grid company before we do this, what we don't do, of course.
Of course we did.
So that's a photo
sorry.
from inside. Really
Sorry. We don't
cheap.
need some now.
Can you turn it around? Oh, we can't see anything anymore. So that's the Chinese box cheap thing from inside, which actually is conform to VDE 0126, so we could attach this. Okay, maybe the show is over.
Yeah, it's over. It's over. No, it's not over. Of course not. I'm sorry, we aren't prepared in a very well.
Yes, we put the coin for a scale in there, just to show you how small you could do that. So
Yes, we did.
that's 5 cents I put in here to have an idea of how much air is in the box. So basically, we could fit it into a cigarette box, I think, if some real technicians go for it. So, connections, are you ready?
I hope so. Should we
Okay.
try the sun? Oh, we've got stage sun. Yeah. Is enough? No, it's not enough. Your sun's cable is too short.
What?
I think we need help from the audience. Would you care to shine the sun onto the photovoltaic cell? Here is an electricity meter. In case you're wondering, those are the cheap, crappy ones from your local Baumarkt. They can count backwards.
but not all of them.
Yeah, it's already on, and the sun isn't shining. Ah, it's working. Well, it's right here. There's a green light blinking on our magic box.
Can the camera show it?
Which actually indicates that we are now putting electricity into the public grid. And there's another problem which we didn't anticipate. Well, I did. And those counters only start at about 9 or 10 watts. So we are putting less than 9 watts into the public grid now. I'm sorry.
Well, if there is no camera with that, it doesn't make sense anyway. Anyway. Okay, we go on then. This works since...
As you might have noticed, it didn't take much time. Most of the time I spent because I'm not well prepared. If you are prepared in a good and wonderful way, it will work in about 2 minutes. It's easy, but it's still not enough sun.
So this little machine has a maximum power point tracking in there. It would adjust to the power that's shined on there and does an optimized feed in. But this technology exists since years, and nobody develops this very small scale gadgets. So there's, from our perspective, a good market because we're so close to a grid tariff that you could actually use it at home on your balcony.
Which I do. Well, now we've entertained you. I hope we did that in a sufficient fashion. Now it's your turn. There's a lot missing from, well, basically from the internet. And there's a lot of information missing. We need opensolarmap.org. What does it do? Well, we've talked about that. It takes one of those wonderful flying helicopter things, and you need a laser pointer and a camera and some fancy software. And finally, you get a solar cataster for every place. For much cheaper. Currently, it's done with a real plane and commercial software. Basically, we need the same for wind. And then there's fun to be had with hardware, solids, and maybe even with fluids. You need one of those boxes as open hardware, so everyone can have one. If thousands and thousands and thousands of people have one, well, Vattenfall has to be convinced they will allow it because, it's reality. And
basically, this grid tie inverter is nothing else. If you have the Tahaka, the thing for your car, you put in 12 volts, you get 230 volts for your laptop in the car. That's the same thing. It's only the synchronization to the net that's different. And the box for the car costs only 40 euros, so this should not cost too much more. And then?
So there's another thing you shouldn't do. You shouldn't take your car alternator, which turns your cigarette lighter into real electricity and connect it to the public grid. That won't work. It will melt and burst into flames, hopefully, because that's interesting. But please don't do that. You need this special box, which currently can only be gotten in China. And there's definitely a need for energy storage technologies. Lead-acid batteries are cheap, but they are heavy, they don't work too well, they contain sulfuric acid, which is bad, and they contain lead, which is bad for the environment. In my dream, I will come here next year, not be on stage, but in the audience, and some of you will show your new redox flow battery. Have you heard of that? Oh, wonderful. How many of you have heard of that? Okay, so I have to explain it. That's basically a battery with exchangeable fluids. If you've got a redox flow battery, you can go up to your gas station, buy some charged battery fluid, off you go, it's recharged. Wonderful. And if you want to enlarge your redox flow battery, well, you get another few bottles of fluid, off you go. Sounds good. And we definitely need a way to get very cheap solar panels. If you care to ask downstairs in the hack center, there's some guy with a 3D printer. I asked him today if he can make solar panels. He said yes, but we didn't do it today because we would need to make a vacuum in this room, which we can't. Go ask him, so it gets cheaper.
So there are other things for cheap electricity generation. That was in the papers last 2 days ago, that there's some paint being invented that gets you 1% of the light that falls in to electricity, so 1% efficiency. So to wrap it up, this is our future. It's dark, it's black,
Oh,
it's not green, from my opinion, because this 1% is photosynthesis. That's the efficiency you get from light that is being transferred to biomass. And that's only the theoretical usage that you can get out of this. This is practical photovoltaics that you can buy off the shelves. 15% of the light that falls in is being converted to electricity. And that should be a chance.
Yeah. That leaves 85% of light wasted. Do something with it. But at least it's 15 times more than plants can do. Sounds good.
So next time you read the papers, think about these numbers.
Well, why not make use of networks? You all love networks, don't you? And what we need is kind of an, well, I've called it energy server. It's a really shitty name, I'm sorry. And if you produce your own electricity, you need to match it up with what you need. It's interesting if you turn on the washing machine while the sun is shining. But you shouldn't need to think about this for yourself. Your home server can do that. So you need a control port. You need a washing machine with some kind of web server in it which can turn it on and off. You need a toaster which can be turned on and off from your home server. Doesn't this sound like fun? And you need fancy server-side software. This is a job for you. And if you've done all of that, go and disconnect yourself from the grid. Team up with your neighbors because it's easier and you get to meet people. And use the sun because it's shining and it's good for people. If you live in the European Union, you will get to know those. You probably know those from your basement.
The old Ferraris counter.
It's not a Ferrari counter because they can't actually go that fast. But well, the EU wants us to have fancy digital electricity counters. Well, what can you do with it? I've been told those things can do communication 2 ways. But I've got no idea what they actually communicate. I've been told those things can actually turn off electricity to a household. This sounds like a denial of service attack to me. Impress us next year, please. Do you have another slide? I don't think so.
No. I just want to mention some communication protocols that are not really good documented, but there's really good chances to integrate different renewables in your home. If you have your photovoltaics, if you have your wind, maybe you have a CHP, a combined heat and power plant, and you want to have that communicate with your actual demand. So that would be work for guys like you. And for now?
Well, ask questions, either now or via email. You have to follow this algorithm so to prove you aren't a spam bot, but shouldn't be too bad. There's time for questions now, I think. Where's our angel? Is there any time left? There's time left, isn't there?
So first question on, well, remark. If you go more global, there's a good book I read a couple of months ago called Renewable Energy Without the Hot Air. Don't know if you've read that. It's free. You can just download it on the net. Just Google renewable energy without the hot air. and it basically makes a whole assessment for whole Europe about running all Europe and renewables. So it's quite a good read, and it's also very well founded.
Next question. Oh, that's easy. More questions? Oh, lots of questions.
Yeah, actually it's not a question, it's an answer, because you asked how much energy there is in Club Mate, and it's 1.2 million kilowatts if you bring it together with anti-mate.
Wonderful. That's a question right down there. Thank you so much. That's impressive.
Hi, just a remark concerning your talk. Thanks for the talk, it's very, very nice. I just want to contrast powering your own gadgets with the vocabulary you use to describe a bright future with renewable energy, and the rather stark vocabulary you use to describe the current coal and fuel energies. But just to be clear, we'll never get, even with 100% efficiency on solar panels, enough energy to even build the calculator, the microwatt calculator you get there. Fuel and coal gets us power density and enormous amounts of power available with tremendous reliability. So I'm just worried about this will not scale. This is very nice to power your own gadget, but not enough power to make the gadget, and certainly not enough power to run all the computers that this gadget is usually connected to. So I just wanted to have your thoughts about this very quickly. Thank you.
Actually, we looked on how much energy there is theoretically in some battery materials, and this lithium sulfuric battery is described with theoretically 3,200 watts per kilo, and watt hours, kilowatts?
Kilowatt hours.
Kilowatt hours per kilo.
Per
So you would have 10 kilowatt hours per kilo in diesel. And if you want to make electricity from diesel, you only have like 30 or 40% efficiency. So
okay, I'm
that's
very
not
sorry,
that
but
much
can I?
of a difference.
I'm sorry to interrupt, but can I ask everybody to stay seated, because it's really interruptive during the Q&A. So thank you very much.
Okay, my point is batteries in theory should do almost the same electricity storage like diesel does at the moment. So I don't see too much of a problem.
And that's another remark from me. Actually, the energy you need to produce one of those panels can be produced by the actual panel in about 6 months. That's called Erntefaktor in German. I don't really know an English word for it. They pay off after some time. The energy you need to build a wind turbine, as you see in Brandenburg, is being produced by that same wind turbine in about a week. After 1 week, it's free.
And usually you don't need to store that much energy like you used to. If you had an old heating system at home, you might have had 2 cubic meters of heating oil there. So that would be lasting for the whole winter. But for the future, you would only need so much electricity to cover the need until the next wind has come and filled up your storage. So that would be quite a bit less.
Yeah.
1, 2, 3, 4 questions now. 5.
Yeah.
You first.
I'm quite a bit disappointed from this talk because what I really looked for was a lot less some vague allegations about the fact that not only there was solar power but that you could actually use it, but rather concrete experience how to construct a small-scale installation of either solar or wind power, and the very nuts and bolts of how that actually does work, because not only is it not trivial, but there is also a patent lack of purchasable and reliable electronics doing the work in the background. And I would very much like to have, at least at this stage, some answers to these kinds of questions.
Okay. Please, people.
Yeah.
Who else is disappointed? Show of hands, please.
No, I'm not really disappointed.
No,
but-
we want to answer this question because basically we a little bit expected this, but with a gadget like this, which is only be accessible at the moment in China, it's trivial. You just plug into the wall and it works. It's for idiots. So just somebody has to build it, and nobody does it. So this is more a motivation thing. Demand something like that. If there's nobody to build it, get somebody you know who's technically able to build it and build it. There were gadgets like this. I had some bought on eBay from German companies. They don't produce it anymore. So I bought these from China, plug it into the wall, and they work. So the thing is, you have the grid tie inverter. It's the same thing like you have in your car. I said you plug in 12 volts that come out of your car, or you take the 12 volts that come out of this photovoltaic thing, and it changes this to 230 DC power. And then you have to have the synchronization and the mechanism that cuts it off the net so that they don't get electrocuted. And that's basically it. That's one, what's it, schalter? Switch.
One switch away.
And one part of electronics that does the synchronization. You have the official net that goes with 50 hertz, and you have to synchronize it that you don't disturb the net, and that does the machine. And everything else is just peanuts.
But I mean, along those lines, did you even... Sorry.
Yeah, there's another question going.
You want to answer? I actually go ahead. I want to have a similar demand. I'm also trying to live off the grid for a couple months, and I do use a small solar system, and I have the need to find other guys who are actually working on getting a small structure together, like you said, because it is missing. There's nothing for below €1,000 or bucks where you can buy a solar setup. It's not there. You have to get the solar panels, you have to get the diode, which is kind of okay, you have to get the thingy and connect everything, but there is nothing like a package or something. Anyway, I would love to share also.
Okay, we'll set up a website where we collect this. I actually reserved one called piratenstrom.de, so maybe we set up as a website for that. Why not?
It would be great to have a package. Anyway, my question is, I'm messing around with the 12 volt, and my idea is not to use to put it back into the system, because 12 volt is more efficient, because that's what you have, and when you lose power. Anyway, I use the batteries, but they are nasty and break, and I thought about using a pump to fill up a 1,000-liter whatever tank, water tank basically, and try to use the power back. Is that reliable? Do you think it is in a small scale usable? Because I'm not too good with calculating that. Would it be useful for like 50 watts or something?
I'd like to offer you that we should meet after this talk. We need to do some number crunching on this.
It's just a rough scale. Would it make sense to play around with water as a
basically, no.
energy, as a battery, basically?
No.
To be honest, no.
No? Okay.
No.
I wonder how photovoltaics really compares to photosynthesis, because you said it's 1% and 15%, and evolution had a few million years, I think, to optimize this technology called tree. And on 1 square meter, I can grow a really huge tree, which has perhaps billions of little solar panels, these leaves. And I can just, I can make this solar power plant out of dirt, literally. and I can burn the wood and generate electricity. And to have these photovoltaic panels, I think there's a lot of ancient sunlight which is stored in oil and gas, which is necessary to produce these things. And my question is, do you have numbers? If I have 1 square meter and I grow a tree or I put a photovoltaic cell on it, what is the real efficiency of these both technologies compared?
That's a good question. The photovoltaic thing, 1 square meter of photovoltaics gets more or less 15% efficiency. We've seen that before. 1 square meter of tree, regardless of tree size, that's the interesting part, gets about, let's say, 1%, might be 2, more or less. And the thing about trees is if you use a larger tree, by getting it to grow bigger, you don't get more sun. So you don't actually get more energy. Increasing the tree doesn't help because it still needs sun and the sun doesn't increase with it. But the problem is if you use the vertical space and you get all your sunlight in your tree up here, there's none left for the below.
That's a constant. We only have so much sun for 1 square meter, and at the moment we can collect 15% with an off-the-shelf solar panel, and in the laboratories we have systems that go up to 40% collection. And that's just a fact. Photosynthesis, look it up in Wikipedia. There's a link for a big study for photosynthesis. In general, you would get like 0.6 or 0.8% efficiency, and that's only the energy that is stored in biomass. If you want to transfer biomass again to electricity, you lose again 50%. So we would not use that numbers because that's getting too amazing then.
The tree is interesting because it produces chemicals. That's a good thing, which you can use for building like furniture, medicine, whatever.
We are not against biomass. You can eat it.
I'm very sorry, but I've got to end it because it's the end of the talk. Where can they find you right now if they want to talk a bit more about this?
Well, I'd say right outside the store.
Yeah.
It's very busy, so that's not going to happen.
Okay. Oh, that's too bad. Suggest a place.
You tell it. I don't know where I can find you.
I don't live here first time.
Maybe in the restaurant or where you're sitting?
Let's say in front of the speaker's room, but not inside the speaker's room because that's for us.
That's okay. Okay, so if you want to talk to them, please find them there.